This video is for Chapter 10, Quasi-Experimental Designs and Program Evaluation for PSY 222, Research Methods in the Psychological Sciences. This chapter moves us in a somewhat different direction. We're going to talk a bit about the ways in which we use research to, typically anyway, address applied types of questions. And by applied we mean in the real world, where we're trying to solve problems that people have, or for example, evaluate the effectiveness of various programs. There are a variety of goals for applied research. Sometimes what we're trying to do is to take findings from the laboratory and test them in an environment that's more realistic. So you may have a kind of, for want of a better way of describing it, a proof of concept with a laboratory finding. Then you want to take those findings and put them to work in a less controlled environment to see if they stand up. And that's what we mean by testing external validity. Generally, our goal is to improve people's lives. Sometimes it's in the workplace. It may be a policy that you're trying to assess to determine if it's effective. Quasi-experiments are often applied, not necessarily, but they are often in an applied context. They're called quasi because the procedures look very much the same as an experimental design. You're comparing groups typically, or you're looking at the impact of a program from time 1 to time 2. What you're trying to do is approximate as close as you can the controlled laboratory procedures, often in an applied type setting, or when you're dealing with naturally occurring groups, such as 2 classrooms of students. Program evaluation is a special case of applied research where you have an existing program and you want to test whether or not it's meeting its goals. So this is the really classic version of applied research, where you're trying to test whether a real-world treatment is actually effective. I've done some of this type of applied research where, prior to it, needs assessments had been done. A program was done in order to meet those needs, and then a post-assessment was done in order to determine whether or not the goals were met. Now, we need to back up a couple of steps before we kind of dive into some of the issues and methods for doing applied research. We need to remind ourselves what are true experiments, because the problems that we have with quasi-experimental designs and applied research are tied to the benefits, the advantages of true experiments. So when we talk about a true, I suppose that should be in quotes, experiment, you are, as the researcher, you're implementing some kind of intervention, the independent variable. It's often called a treatment, and you're putting it into play. So, for example, you have a reading program. You want to see if it improves reading test scores. You're going to implement that treatment and then determine whether or not it is effective. Now, true experiments, it's more than just the manipulation of the independent variable. It's also the high degree of control that you as the experimenter have over the experimental conditions. The random assignment of participants, the systematic manipulation of variables, the very careful and systematic measurement of dependent variables. All of those things, when they are carefully controlled and you've balanced for any number of competing possible causal variables and kept those held constant, that allows you to make causal conclusions. This is particularly true for the random assignment of participants to experimental conditions. And that's often seen as the hallmark trait of true experiments. In a true experiment, one of the other critical features is the fact that you are creating a comparison group. So the whole point of random assignment of participants to groups is that you are creating a control group, a comparison group, sometimes more than one comparison group, to serve as the baseline in a way. And then if by random assignment, you're making sure that those people are initially equivalent to each other. And then you can really determine if the manipulation of the independent variable is the causal factor, or at least most likely is the causal factor. There are obstacles, though, to conducting true experiments with random assignment of participants, with all of those control procedures in place in a natural setting. So imagine if you had a potentially effective treatment for a disease, and you want to go into the community and randomly assign people to either get the treatment or not get the treatment. That makes people kind of mad when you do that, because you're denying some people a potentially therapeutic treatment. Even in a more benign kind of situation, the ability to actually just practically go in and randomly assign participants to controlled circumstances means you would almost functionally have to hold them hostage in order to be participants. And by doing so, you're negating the advantages of natural settings in terms of their increase of external validity. So one barrier that we have to doing true experiments with all of the hallmarks of what a true experiment is getting people to be willing to participate and getting permission from organizations to do the research at all. You think of school environments, workplaces, hospitals, prisons, any kind of organizational structure. Getting access to do experimental research in its truest form is going to be a challenge, especially if you're talking about trying to control where people go, what they do, who they have exposure to, and so on. Not only are there ethical issues there are also just simple pragmatic issues as well. Random assignment is sometimes perceived as unfair by people. As the example I gave a little bit ago, where if you have a potentially effective treatment for a problem that people have, people will want the treatment, particularly if they're ill or they're suffering, and they won't want to be randomly assigned to the control group. One way around this is to do what's called a waitlist control group, where you have you randomly assign participants to experimental and control groups, but you promise the control group that after a sufficient amount of time to test efficacy in the experimental group, you will provide the treatment to the control group. And still, some people will perceive this to be a fairness issue, so you end up having a selection issue with who's willing to participate and who's not. So there are many obstacles in the way of doing true experiments in real life settings. So we have to have methods that we can use that are effective, that are efficient, that are ethical in naturalistic settings. Before we move on to talk about some of those methodologies, we need to spend more time talking about threats to internal validity that we can address with true experiments, but we can't with quasi-experiments. There are many different threats to internal validity. We've touched on a few of them as we've moved our way through this course, but we need to look at them much more carefully now that we're this far in. We often call threats to internal validity confounds, and what we mean by a confound is it, you have the independent variable. You want to be able to isolate the independent variable as a potential explanation of any effects that you see after you manipulate that independent variable. A confound is some other variable that you haven't controlled for, and it may have exerted an influence on your dependent variables of interest. There's a long list, and we're going to look at each of them separately. There are major classes of threats to internal validity, and they include history, which is events, maturation, instrumentation, regression, attrition, selection, and additive effects. We're going to look at each of these separately. So first we have history, and this is what happens if an event occurs that you didn't plan on, and you have no ability to control for, but it threatens the internal validity because it may or may not have had an impact on people's behavior. So sometimes these are just unforeseen events that you couldn't have predicted. For example, I'm collecting data right now on the experiences of people who foster dogs, and I started collecting data before the pandemic started, and I've continued to collect data. Well, the pandemic is a naturally occurring historic event. It's had a major impact on people's willingness to foster dogs because they're all locked at home. We have more of them, right? So that's a perfect example of a history event that can potentially, anyway, impact the results of my study. True experiments require that you control for their historical experiences or their history of experiences by controlling for things like you collect the data in the same room with the same equipment, with the same temperature. You vary the time of day so it's counterbalanced. You do all these things to eliminate historical influences, such that the only thing that's varying, that's different across your groups, is the actual manipulation of the independent variable. In natural settings, you don't have that ability. You cannot create in a natural setting because it would make it not natural. You can't do that. So the historical experiential differences can have an impact that you can't control. So you have to kind of think about it and plan for it. But at the end of the day, you're not going to be able to control it. Now, here's a concrete example. Let's say that you're studying whether a recycling awareness campaign on a campus influences the amount of recyclables put into the campus bins. A history threat would be if, let's say, just by happenstance, some major celebrity decides to put out tweet after tweet or Instagram after Instagram, or heaven forbid, TikTok after TikTok about recycling, and it kind of goes viral. Well, if you're thinking about when you started your intervention right here, and right about the same time, maybe just ahead, the celebrity goes viral with their "let's all recycle" message. Now, if that message is timed at the same time as your intervention, you have no way of determining whether or not your campaign was effective or if it was the messaging by the celebrity. So the fact that happened just by happenstance means you will likely have to repeat your experiment at a later time. Maturation effects are basically, participants continue to change over time. I think the name here is an artifact of looking at, immature organisms who are still growing, children, for example. But all people, regardless of their age, continue to grow and change in various ways. So participants in an experiment, it's less vulnerable if it's a short-term experiment, more vulnerable to maturation if it's long-term, but people change as a function of time. In if the change, if we're talking about maturation effects, just the simple passage of time can lead to changes in behavior. So that's what's called maturation effects. Now, an example would be, let's say we're trying to study reading comprehension in children, and we're deciding to implement a new reading program in second graders. And what we find when we look at this pre-post comparison in our second graders is that there appears to be a dramatic increase. Well, what we know, though, regardless of whether they are in this program or another program, reading comprehension tends to improve generally, regardless of what kind of program, as children mature across a school year, assuming basic levels of competent teaching. So we don't know for sure whether this is just a maturation effect or if it's the actual program. So, you know, what you would need is a comparison group, obviously. So that's a maturation effect. A testing effect is caused by just the fact of, and you know this, when you get practice taking certain kinds of tests, it's why probably you took practice SAT tests or something like that to prepare for a big test. When you practice, you learn strategies. So taking a test generally impacts our performance on similar tests going forward, especially if they are tasks where learning a strategy for solving the problems tends to be effective with other similar problems. So a testing effect tends to be seen as a threat to internal validity if you can't separate out your independent variable from the natural tendency of people to learn how to adapt to particular tests. So here's an example of a testing effect. And in this case, you're saying, does a new problem-solving strategy influence the ability to solve problems quickly? Well, you have speed, you're measuring the speed of problem solving, and from pre to post, you do see that it takes people less time to solve problems. Now, is it the new strategy, or is it just the fact that they've gotten slicker at your test because they're now familiar with it on the second try? So it may not be your strategy. It may be that they just, now that they've seen the test before, a similar test, there's less confusion just associated with a novel task. So that means you can't separate out the testing effect from the effect of teaching someone a new problem-solving strategy. Again, the solution to this problem is to have a comparison group. An instrumentation effect, and I've always thought this needed a different name because, you know, right off the bat, you start by talking about human observers, and then you have to call that an instrumentation effect. People aren't instruments, but in this case, you have to think of, what are we using to collect the data? What are we using to assess the behavior? Sometimes it's an observer, a human being, who is assessing the behavior, counting behaviors, categorizing behaviors, for example. A human observer, therefore, is a kind of quote-unquote instrument. As humans, though, we are prone to bias, we get tired, we have expectations, we have our own unique characteristics. All of that can represent an instrumentation effect. If we don't control for these problems, like observer bias, that's an instrumentation threat to internal validity. We also use mechanical instruments in addition to human observers. And there is a preference in experimental research to using mechanical instruments because they tend to be more reliable and they're not capable of bias. So these mechanical instruments, though, they do age. I know there was a period of time we had a device that was used to measure reaction time and uh, it got glitchy after a while. It's kind of like a clock that doesn't keep time properly. It's not really any use as a clock anymore if it's always getting slow over time. And that's what happened with one of these devices in the lab. So mechanical failures that increase with time or with repeated use, that's an instrumentation problem. There's also, you can consider it an instrumentation issue when regulations or codes for describing certain kinds of behaviors, they may change. Like what happens if the state creates a new standard measure of reading and it comes with a new test? Well, you've changed basically the metric. And what if you were trying to evaluate your reading program over a series of years and the government regs change on what good reading means? That's going to affect the way in which your study plays itself out. So for example, let's say that a campus creates a protection program designed to increase assault incidents on campus. The time of the implementation on this graph is at week X, and you look at the line here. What if at the same time, and what you're relying on for your dependent variable is reported assaults. What if at the same time you implement your program, there's a change in the actual reporting laws about what's considered assault, and it has been broadened. So more behaviors constitute assault, and therefore you can arrest people for that behavior. So there you would have more arrests and an increase. So does this mean your program was effective or was a complete failure? You don't really know, because this change in the number of reported assaults could simply be due to the fact that the number of assaults, it appears to go up, but it's really a change in reporting laws that have made it so that more people are engaging in behaviors that now qualify as assault when they previously did not. Now, regression refers to not the statistical technique of regression and correlation, but instead statistical regression as a threat to internal validity is when maybe you select a group of individuals based on their performance at time A. That performance at a single moment in time may not be representative of their performance on average. And over time, people's performance tends to regress to the mean. It's kind of like, an athlete has the season of their life. Well, it's the season of their life because it's not normal, meaning they're going to regress to the mean. If you take their whole career and produce averages, that's the mean. Their best year, that's the extraordinary. So the extreme score, let's say you're selecting your participants based on their extreme scores at point A in time, and you kind of cherry pick them. Well, their performance may decline, not because of anything you did, but because they're regressing to their mean level of natural performance. So basically, the idea is that extreme scores on any one test aren't likely to be that way on a subsequent test. We often call this regression to the mean. This is more likely to happen if the behavior is highly variable or your measure is unreliable. So, my example of athletic performance is dependent on a whole lot of factors. So it's kind of inherently unreliable. In psychology, if you have a test that you're using to assess some sort of cognitive skill, for example, but your measure is lacking in reliability, meaning people will perform one way at one point in time and another way at another point in time. It's just an unreliable instrument. If that's the case, you're going to get a lot of inconsistency in performance over time. So in this example, suppose you have students selected for an enrichment program, and because you're selecting them based on high scores on a test, and it's a brief test. What might happen is that you have a pretest score at point A in time and a drop at post-test. Does that mean that the program was ineffective? Probably not. If you're using an unreliable short test in order to assess ability at the pretest, the short test, maybe just by random bad luck, they were fairly easy questions on the brief initial test. And maybe the post-test, you get a random sampling of questions and they're harder questions. That's unreliability of the measure. So the fact that you give those tests at different times and it's a different random sampling of questions, you may see a regression to the mean where you are having people show a decrement in performance just by the fact that they're taking a second test that is unreliable. And that concludes part 1 of chapter 10.